Okay, let's do this last video for this section, 10C, no, 11, sorry, 11C, not going backwards, page 103. So this set of examples has to do with your denominators being opposites. So we had common denominators, adding and subtracting in the last couple sections, and this section deals with what happens if your denominators are, they're not common, but they're not totally uncommon either. They're opposites. So the process here is that we are going to change the denominator for the second fraction to match the first denominator exactly. And when you do this, you are going to have to change the sign of the middle term, or of that connects the terms together. So this is the same thing as really sort of multiplying through by a -1. And you know, the reasoning here is that you can write a fraction, a negative fraction, in 3 different ways. And we already talked about that. You can put the negative sign in the numerator, the denominator, or right out in front. And so in this example right here, if we decide to take this negative sign, this negative fraction, and put it right out front, it would be plus a minus, which is a minus, and it looks like this. So this 6 becomes positive, but this positive becomes negative, and you end up with 2/6, which reduces to 1/3. So that's what we're going to do as we run through these examples. So we're going to notice, first of all, that the denominators are opposites. And you got to look closely, make sure they're opposites, and all of these are. So you are going to rewrite the first fraction just like it is. You're going to change the sign in the middle. And then you are going to write the second fraction with the same numerator, but the denominator will be the same as the first one. So this is what the change looks like. So now we go back and do what we did on the pages before. Common denominator, x minus 3, factor. We can factor out a 2. The x minus 3's will cancel, and your answer is 1/2. Second example, I noticed that my denominators are opposites, so I am going to write them as the same denominator, and I'm going to change the sign in the middle. When I do that, this numerator stays the same. Nothing about the first fraction changes at all. This guy, his numerator stays the same. The only thing that changes is the sign in the middle and the second denominator. So now, common denominators, single fraction bar. We notice that we are distributing a negative to both of these terms, so this becomes a -6y minus 7. We've got to clean up the numerator, a +7 and a -7, add to 0, y squared minus 6y. We can factor out a y, so we have y minus 6. And in the denominator, we can factor out a y also, and we get y minus 2. And the y's will cancel, and that's the answer. 2 more. Nothing different about this one. We notice the denominators are opposites. We are going to write them such that the second fraction has the same denominator. We're going to notice that this is a subtraction problem, so we're going to make it addition. And everything else in the numerator stays the same. So single fraction bar, a squared minus b squared. I hope you're seeing the difference of 2 squares. A plus b in the numerator. So a plus b over a plus b, a minus b. Those cancel, and 1 over a minus b is your final answer. Don't forget the 1 in the numerator. Last example on this page. Denominators are opposites, make them the same. Change the sign in the middle and bring both numerators down. Single fraction bar, r squared minus 5r. We have r plus 5 minus r. The r's cancel. I'll just go ahead and write this. R plus 5 minus r. The r's cancel. The numerator is 10. In the denominator, we can factor out an r, and we get r minus 5. And you are done, because there is nothing that will cancel. This, I think, is the first one where we've had something that won't cancel in the numerator and denominator after you write it with a single fraction bar, but in reality that really does happen a lot. So don't just be canceling something because you think you have to cancel. You have to make sure that it's a common factor in both the numerator and denominator. Bye. Thanks for listening.